Hello, everybody. Welcome to this session. This session is about the Oracle Database Operator for Kubernetes. Why should you care? My name is Kwasi Mensah. You can see what I do on my Twitter handle. Here is the agenda. We will briefly describe what the Oracle Database Operator for Kubernetes is. Then we will walk you through different database configurations managed by the operator. Then we'll talk about our features summary and a roadmap. What do we have ahead? And then answer the ultimate question, which is, why should you care? You can get the operator on this GitHub repository. But first of all, let's define why Kubernetes operator. Kubernetes has been around for a while, and it's known to help orchestrate containerized applications. You set goals in YAML files, and Kubernetes attempt to meet those goals. DevOps practitioners and developers have been using Helm charts to deploy simple applications in Kubernetes. In fact, they package together a set of YAML files as templates and use those and replicate those templates on different locations, different places. However, Helm charts are good for simple applications, but not well adapted, not well suited for complex stateful applications. That's where the operator patterns comes in. So the Kubernetes operator helps manage, deploy complex stateful applications. And the database is a complex stateful application from Kubernetes perspective. Right. So in a nutshell, a Kubernetes operator is a set of custom resources and then a set of corresponding controllers that implement the life cycles, the management of the life cycles of those custom resources. The Oracle Database Kubernetes Operator, or ODO for K8S in short, and our tagline is make the Oracle Database Kubernetes native. Anyway, you install the operator through the kubectl apply command using this YAML file, and we have a set of YAML file, a template. We have a set of YAML file templates on the directory config/samples from the root of the repository. The picture on the left shows you how this works. So we have the operator deployed in a Kubernetes cluster, and we have a set of controllers, controller for managing the lifecycle of containerized databases. I'll talk about this later. Controller for managing the lifecycle of autonomous database. I'll talk about it. And as part of our roadmap, not in this first release, but as part of our roadmap, controller for managing the lifecycle of on-premises databases. And you can see some of the features, the operations here, but I will come back to those. Now let's look at how the operator can be used to manage the lifecycle of autonomous databases. We'll quickly go over provisioning, binding, scaling up, stopping, and terminating an autonomous database. Of course, you use the operator not for just single database, but you use it for hundreds, several databases, and the idea is you will automate those tasks. So you're not going to sit there at the dashboard and be keying in kubectl commands. Okay, so we assume for this release that a container database has already been provisioned. That's known as the infrastructure. Okay, so in this release, we are not managing the lifecycle of the infrastructure or container database. We assume it has already been provisioned. We will, however, manage the lifecycle of the autonomous databases that will plug into the container database. And in this release, we are only supporting shared infrastructure. So autonomous databases on shared infrastructure. So how do we provision an autonomous database? You need to get what is known as the compartment. You need to get the Oracle Cloud Infrastructure compartment in which you want to provision your database. Okay, you can get it by navigating through the Cloud Console, or you can use the OCI command line interface to get the OCID. Now, on your client machine or from your operation scripts, you will create a Kubernetes secret to hold the database password. Here we are putting the password on the command line, but this is for demo purposes. In real life, we recommend using a wallet or OCI Vault or third-party vaults such as HashiCorp Vault, for example. Anyway, you get the password, you create the secret, and then you edit the YAML file. You take the template, you edit, and you set the OCID that you have copied from either the console or some other means, and you set the admin password for the database. And then you apply the kubectl command. The kubectl apply will send the YAML file and everything you have defined to the operator, to the controller which is specific to the autonomous database, and the controller will do its job. So after a while, you can check using OCI commands that the database has indeed been provisioned. You can see it's available. How to bind to an existing database, autonomous database. So you have an autonomous database, but it's not known to the operator. So you need to bind it to the operator so the operator can manage the life cycle of that existing autonomous database. So the way you do that is you need to find the OCID of the database in question, either by going through the Cloud Console or some other means. As I said, you can use the OCI command line interface to find the OCID. So that can be automated. That's what I'm trying to say. Once you get that, you need to edit the YAML file and set the OCID of the database you want to bind and specify what you want to do, right? And then you apply kubectl apply with the YAML file you have edited, and it will send, and suddenly when you check the status of the database, it's now available and known to the operator, available from the operator perspective. How to scale up an autonomous database. Scaling up means increasing or decreasing, scale up or scale down, the number of OCPU or storage. In this example, we will only look at scaling up the number of CPU. So once again, I think you started to see the technique, right? You edit the YAML file and you specify your goal. Here we want to reach CPU count equal 2. We save the file and we kubectl apply. Request will be sent. And when we check the status, we should see that the database now has 2 OCPUs. How to stop an autonomous database? Well, same pattern, right? You edit the lifecycle, you set your goal, what you want the operator to do, and you save, you kubectl apply, request will be sent, and you can check the status. You will see the database has been stopped. Next, I want to terminate an autonomous database. For that, we recommend using something we're calling hard link. So you need to set hard link to true. Same pattern, you need to edit the YAML file and set hard link to true, right? And then save the file and kubectl apply the YAML file. And then the controller will delete. You can use kubectl delete -f, the YAML file, okay? So the termination request will be sent and the database will be terminated, right? Okay. Now let's talk about how to use the operator to manage the lifecycle of single instance databases. Those are databases deployed in Docker containers. And when we say single instance, we're talking about standard edition, enterprise edition, or XE, which is the express edition, which is free to use, free to deploy, etc. So we will quickly go over how do you provision the Docker image of the database? How do you clone a single instance database? How do you use Enterprise Manager for observability? How do you patch? And how to update database configuration. I'm not sure we cover that, but this is something you can do. So to provision an image, a Docker image of the database, you can either get it from our GitHub repo, which is here. Let me move the picture here. You can see the GitHub image here. So you can pick the release that you want. And then alternatively, you can use pre-built database images from the Oracle Container Registry. So the previous slide, you have to build the image, the Docker image yourself. But here, you can just use a pre-built Docker image. And here is the YAML file of single instance database. This is the template. You can edit a set of fields in there, save, and kubectl apply. So as I was saying, you need to edit and apply. And here we are editing the file, setting some values, and then kubectl apply. And then when you say kubectl apply, you need to wait for a moment, and then you will see that the database is up and running. It's in a healthy state, right? From there, an endpoint will be exposed where you can use Enterprise Manager Express to see in the next slide a dashboard of your database. So this is a sort of observability offered by EM Express over containerized database deployed in Kubernetes. And you can also check, you can use a SQL plus command to connect from outside into that database, which is in the container. Here is the Enterprise Manager Observability Console that I was talking about. So it does not provide a full-fledged of all the EM capabilities, but this is good enough for having an idea of what's going on with your database that you have provisioned. In terms of patching, you need to use what we're calling the extension. You have the patching extension from GitHub. You need to build a patch image from GitHub. And then you need to ensure that the database is in a healthy state before patching. You apply the command here. This is the kubectl type equal merge, blah, 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 all these commands, okay? All these are in our documentation, okay? So, and then you need to update the custom resources and with the patched image, and the database goes into patching mode, and after a while, you will have a healthy database which has been patched. That sort of gives you a short summary, and we have more features coming in the next drops. I just give you a very brief summary of everything you can do with single instance database deployed in Kubernetes. Now let me talk about how to manage the lifecycle of sharded databases. Those are sharded databases in the Kubernetes cluster. So sharded databases are a set of databases managed by an infrastructure, the shard director or the GSM, etc. For that, we will provision 6 nodes OKE cluster, okay? And then we will show you how to add a new shard and how to delete an existing shard. This is a very complex development work to get this sharded database working in Kubernetes. So what we're seeing here is the 6-node Kubernetes cluster and everything you have to do. So step 1, you need to add the specification. And you can see here that we have specification for GSM1, GSM2, the catalog, the shard catalog, and then specification for shard 1 and specification for shard 2. So we will have 2 shards in the same group. And as you can see here, after you edit the shard, the YAML, you need to save and apply, kubectl apply, and then wait for a few minutes, and then you should see working databases and the topology available in the Kubernetes cluster. And you can verify that there is a sharded configuration. Here we see 2 shards in the same shard group. Okay, so we do have a sharded database actively in the Kubernetes cluster. Now let's see how to add a shard. We will add a third shard to the cluster. To do that, same pattern, we need to edit the YAML file and add the specification for the third shard, save and apply the YAML file. And then after a moment, you should see that shard 3 is added to the existing database shard topology. And when you verify the database configuration outside of kubectl, here we are using the gdsctl command, which is the specific to the sharded database. We can see that we have 3 shards, and these are all part of shard group 1. Okay. Now let's try to delete an existing shard. Same pattern, you need to edit the YAML file and add isDelete equal true as part of the specification of the specific shard that you want to delete, right? So when you do that, you need to save and kubectl apply. Then what will happen is, as this shard has data, we need to move out data and spread over the other shards. And that's called a chunk movement. The manipulation of sharded database happens at chunk level. We don't move block by block or row by row. We move chunk by chunk. So a shard is a set of chunks. So you should see a chunk movement. So chunk being removed from that shard, which is up for deletion, and spread over the existing shards. Okay, so after the shard chunk operation is over, the database, the sharded database, should be removed or deleted. And when you check the status, you should see from the operator that it's terminating. And if we look here, we should not see that shard anymore. Shard is terminated by DB operator post shard movement. Okay. That sort of concludes the summary of the capabilities that we have in this release, which is the first drop, the first release of the Oracle Database Operator for Kubernetes. Let me talk a little bit about the features summary and our roadmap. In terms of features that I just describe to you very briefly. You can see here that we have we can manage the life cycle of two categories of databases. The off-cluster databases, meaning databases which are in the cloud but not in the Kubernetes cluster. And that's typically the autonomous database. There are other databases, but for this release, we are only managing the lifecycle of autonomous databases. And you can see that those autonomous databases are on shared infrastructure. So we can manage the life cycles of all workloads, autonomous transaction processing, autonomous data warehousing, autonomous JSON data, and application express database service. And you can see all the operations: bind, provision, start, stop, terminate, scale up, down, etc. Now, the second category is databases which are deployed in the Kubernetes cluster. And in this release, we are supporting single instance databases. As I said, Standard Edition, Enterprise Edition, Express Edition. And we can do the provisioning, we can clone, we can patch, update init parameters, and update database configuration. I did not show those in my presentation, but these are supported. And then sharded databases, deploy a shard topology, add a shard, and delete a shard. In terms of roadmap, this is not an exhausting list. This is a non-exhaustive list of things we have on our roadmap. So the first is certify the operator against third-party Kubernetes cluster. We have requests from customers who have heard about the operator and who are using third-party Kubernetes cluster. So we're going to certify the operator on third-party Kubernetes cluster or third-party clouds. The second is OLM integration, the operator lifecycle management framework. It's a matter of time, we get this done. It's just we could not get all those things done for the first drop. And then publishing the operator on operatorhub.io. This is paperwork. We just need to do the paperwork the legal paperwork in order to get this done. In terms of autonomous databases, as I said, we will in next releases support the lifecycle of the infrastructure in itself. For example, we will be able to provision a container database. And from there, we can also manage the lifecycle of dedicated autonomous databases. In other words, autonomous databases on dedicated infrastructure, as opposed to autonomous databases on shared infrastructure that we are supporting in this first drop. We will support on-premise databases on-premises, so databases made of container database and PDBs deploy on your Linux, for example, on-premises. The operator either deploy in Kubernetes in the cloud or deploy on Linux on-premises will be able to manage the life cycles of on-premises databases. In terms of containerized databases, we will support a rack cluster deployed in Kubernetes. We have already announced rack in Kubernetes, but it's not yet managed by the operator. So in the roadmap is the operator will manage the lifecycle of rack databases deployed in the Kubernetes cluster. And then we will REST enable the database, the containerized databases. For example, provide ORDS, which is the Oracle REST data service, as a mechanism by which we could do SQL over REST against databases deployed in the Kubernetes container. And we will also offer the low-code application declarative application deployment, known as Application Express. By virtue of having the ORDS bridge, we should be able to support that. Of course, we will also provide cloud native observability, and I have one slide on that, and much more. Here is the slide, the summary of the cloud native operator observability. In fact, we will provide controllers to do metric export, log exporter, and those will feed Grafana, Prometheus, Loki, Prompter. So at the end of the day, you will have a Grafana dashboard with data coming from the exporters that we have deployed. So the exporter will be able to export metrics and logs from not just the databases, but applications, in fact, microservices deployed in the Kubernetes. But from the operator, database operator perspective, we are interested in the metrics of databases that have been deployed in the operator, right? But we could support more than that. That's what I'm trying to say. So why should you care? That's the ultimate question, right? So the first is, I think we all agree that Kubernetes is primordial for DevOps CI/CD pipeline. This is very important, and many companies have embraced Kubernetes as part of the CI/CD pipeline. The second reason is you have adopted Kubernetes operator pattern for automating the lifecycle management of complex and stateful applications such as databases. So you have adopted the operator pattern. You are using or you plan to use Oracle databases in your DevOps, right? So those are three reasons to care about the operator, the Kubernetes, the Oracle database operator for Kubernetes. The other reasons are that Oracle is resolute in making the Oracle database Kubernetes native, which means our databases will be observable by Kubernetes and operatable by Kubernetes. This is a firm commitment from the company. We are not doing something like, it's not fashionable. We are doing it because we believe and we are embracing Kubernetes fully. The last thing I want to say is that the operator is open source. There is no vendor lock-in, etc., etc. Thank you so much for attending the session.